Happy morning, students. Coming back to chapter 13, surface area and volumes, exercise 13.1. Let us see the formula for finding the lateral surface area and the total surface area and the volume of a cube. For a cube having an edge A units, we have the lateral surface area formula will be 4a squared square units and the total surface area will be 6a squared square units, and the third one, volume of a cube will be a cube cubic units. Cuboid. For a cuboid of length L, breadth B and height h, we have lateral surface area of a cuboid is equal to 2 into L plus B into h square units. Total surface area is equal to 2 into LB plus BH plus LH square units, whereas volume is equal to L into B into H cubic units. Cylinder. For a cylinder of base radius R and height h, we will have the curved surface area of the cylinder is equal to 2 pi RH square units. Total surface area of a cylinder is equal to 2 pi RH plus 2 pi R squared. So taking 2 pi R commonly outside, I will be having 2 pi R into H plus R square units. Volume of the cylinder is equal to pi R squared H cubic units. Cone. Consider a cone of base radius R and height h and slant height L. L is equal to square root of h squared plus R squared. So we have the curved surface area of the cone is equal to pi RL, and the total surface area of the cone is equal to pi RL plus pi R squared. Volume of the cone is equal to 1 by 3 pi R squared h cubic units. Sphere. For a sphere of radius R, we have the surface area of the sphere is equal to 4 pi R squared square units, and the volume of a sphere is equal to 4 by 3 pi R cube cubic units. Hemisphere. For a hemisphere of radius R, we have the curved surface area of the hemisphere is 2 pi R squared square units. Total surface area of the hemisphere is equal to 3 pi R squared square units. Volume of the hemisphere is 2 by 3 pi R cube cubic units. Coming to exercise 13.1 in surface area and volumes. First problem, two cubes each of volume 64 cm cube are joined end to end. Find the surface area of the resulting cuboid. Given the figure, where the figure has been formed by joining two cubes, we need to find out the side of a cube. We can find the side of the cube by using the volume of a cube. So let the side of the length of the cube be x. X cube is equal to 64. X is equal to cube root of 64, which is equal to 4 centimeter. So I got the side of the cube as 4 centimeter. Now I want to find out the surface area of the resulting solid. Cubes are joined end to end. Dimensions of the resulting cuboid will be breadth is equal to 4, height is equal to 4, and length is equal to 8 centimeter, where the length can be got by adding two sides of the cube. We know that the formula for finding the surface area of the cuboid is 2 into LB plus BH plus LH square units, where L is the length, B is the breadth, and H is the height of the cuboid. Substituting the value of L, B and H, we get 2 into 4 into 4 plus 4 into 8 plus 4 into 8, getting 2 into 16 plus 32 plus 32, which is equal to 2 into 80, which gives 160 centimeter square, which will be the surface area of the resulting cuboid. Second problem, a vessel is in the form of a hollow hemisphere mounted by a hollow cylinder. The diameter of the hemisphere is 14 centimeter and the total height of the vessel is 13 centimeter. Find the inner surface area of the vessel. Given the vessel, which is made up of the combination of a cylinder plus a hemisphere, we find that the radius of the hemisphere will be equivalent to the radius of the cylinder. So I am writing, let the radius of the cylindrical part will be equivalent to the hemispherical part. So I am taking it as R. So given the diameter of the hemisphere is equal to 14, so radius will be 14 divided by 2, which is equal to 7 centimeter. We can also say that the height of the hemisphere is equivalent to the radius of the hemisphere, which is 7 centimeter. Now the height of the cylindrical part can be got by subtracting the total height of the vessel minus the height of the hemisphere, which is equal to 13 minus 7, which is equal to 6 centimeter. Now I need to find out the total inner surface area of the vessel, which can be found out by CSA of a hemisphere plus CSA of the cylinder. Total inner surface area of the vessel is equal to pi r squared plus 2 pi rh. Substituting the value of r and h here, we will be getting inner surface area of the vessel is equal to 2 into 22 by 7 into 7 into 7 plus 2 into 22 by 7 into radius is 7, height is 6, equal to 44 into 13, which is equal to 572 centimeter square. Fourth problem. A cubical block of size 7 centimeter is surmounted by a hemisphere. What is the greatest diameter hemisphere can have? Find the surface area of the solid. Coming to the solution, he has given a figure of a cube where the hemisphere is surmounted on a cubical block. Given a cubical block is surmounted by a hemisphere, we have the greatest diameter will be equivalent to the cube side of the cube, which is equal to 7 centimeter. Radius of the hemisphere will be equivalent to the diameter divided by 2. The diameter is 7, so 7 divided by 2, which is equal to 3.5 centimeter. The total surface area of the resulting solid will be equivalent to surface area of a cube plus CSA of a hemisphere minus of the base of the hemisphere, which is a circular region, equal to 6 into side square plus the CS of a hemisphere is 2 pi r squared minus the base area of the hemisphere, which is the area of a circle, so minus pi r squared. So 2 pi r squared minus pi r squared will give pi r squared along with 6 into side square. Substituting the value of the side square, the radius of the circle, we get total surface area of the solid is equal to 6 into 7 squared plus pi r squared is 22 by 7 into 7 by 2 into 7 by 2. Further simplifying, I will be getting 294 plus 38.5, which is equal to 332.5 centimeter square. Sixth question. From a solid cylinder whose height is 2.4 centimeter and diameter 1.4 centimeter, conical cavity of the same height and the same diameter is hollowed out. Find the total surface area remaining solid to the nearest centimeter square. He has given the figure of a cylinder. Inside the cylinder, where the shape of the cone is hollowed out. Coming to the solution, it is given that the height of the conical part is equal to the height of the cylinder. So where the height of the cylinder is given as 2.4, so therefore the height of the cone is also equivalent to 2.4 centimeter. The diameter of the cylindrical part will be equivalent to the diameter of the cone. So he has given the diameter of the cylinder is 1.4 centimeter. So my diameter of the cone will be equivalent to the diameter of the cylinder, which is equal to 1.4 centimeter. So I am writing the radius of the cylindrical part is equal to 1.4 divided by 2, which is equal to 0.7 centimeter. Now I need to find out the slant height of the conical part, which can be found out by using square root of r squared plus h squared, which is equal to square root of 0.7 the whole squared plus 2.4 the whole squared. So which is equal to square root of 0.49 plus 5.76, which is equal to square root of 6.25, which is equal to 2.5 centimeter. Surface area of the remaining solid, which can be got by CSA of the cylindrical part plus CSA of the conical part plus the base area of the cylinder. So which is equal to 2 pi RH plus pi RL plus pi R squared. Substituting the radius and the height of the cylinder, of the hemisphere and the radius of the circle, can write as 2 into 22 by 7 into 0.7 into 2.4 plus 22 by 7 into 0.7 into 2.5, where my slant height is 2.5, plus 22 by 7 into 0.7 into 0.7. Further simplifying, I will be getting 10.56 plus 5.50 plus 1.54, which is equal to 17.60 centimeter square. So the total surface area of the remaining solid to the nearest centimeter square is 18 centimeter square. exercise 13.2. So in this exercise, we are going to see the volume of the given solids. First problem, a solid is in the shape of a cone standing on a hemisphere with both the radii equal to 1 centimeter. The height of the cone is equal to its radius. Find the volume of the solid in terms of pi. He has given the solid, which is a combination of a cone. We need to find out the volume of the given solid. Let h be the height of the cone and r be the radius of the cone. The radius of the hemisphere will be equivalent to the radius of the cone. So I am writing the radius of the cone as 1 centimeter. Also it is given that the height of the cone is equal to its radius. So my height of the cone will be equivalent to 1 centimeter. It is given that the radius of the cone will be equivalent to the radius of the hemisphere. I am writing that radius of the hemisphere is equal to radius of the cone, which is equal to 1 centimeter. Also in the hemisphere, the radius will be equivalent to the height of the hemisphere. So my height of the hemisphere will be equivalent to 1 centimeter. Now volume of the solid can be found out by adding volume of a cone plus volume of a hemisphere, where we have the formula for volume of a cone is 1 by 3 pi r squared h plus volume of a hemisphere by 3 pi r cube. Substituting the values and height of the cylinder as well as the radius of the hemisphere, we get 1 by 3 pi into 1 squared into 1 plus 2 by 3 pi into 1. Simplifying, I will be getting pi by 3 plus 2 pi by 3, getting 3 pi by 3. 3 gets cancelled. So I have pi centimeter cube. Third problem, a gulab jamun contains sugar syrup up to 30% of its volume. Find approximately how much syrup we found in 45 gulab jamuns, each shaped like a cylinder with the two hemispherical ends with length 5 cm and diameter 2.8 cm. Given the figure where the 45 gulab jam are placed inside, we want to find out the volume of the sugar syrup contained in 45 gulab jams. The gulab jam, which is a combination of two hemispherical ends with the cylindrical part, the diameter of the hemisphere is 2.8, which is equivalent to the diameter of the cylinder. The height of the gulab jam is 5 cm. The height of the cylinder can be got by subtracting 5 cm minus 2 into the radius of the hemisphere. Radius of the cylindrical part is equal to the radius of the hemispherical part, which is equal to the 1.4 centimeter, and the height of the cylindrical part is equal to 5 minus 2 into the length of the hemisphere, is equal to 5 minus 2 into 1.4, which is 2.2 centimeter. So volume of one gulab jam can be found out by adding volume of the cylindrical part plus volume of two hemispherical part, equal to pi r squared h plus 2 into volume of hemisphere is 2 by 3 pi r cube. So substituting the value of r and h of a cylinder and the radius of the hemisphere, we get pi into 1.4 the whole square into 2.2 plus 4 by 3 pi into 1.4 the whole cube. Simplifying, I will be getting 13.55 plus 11.50, which is equal to 5.05 centimeter cube. The volume of 45 gulab jam, which is equal to 45 into 25.05, which is equal to 1127.25 centimeter cube. I want to find the volume of sugar syrup, which is equal to 30% of the volume. So we get 30 by 100 into 1127.27, so which is equal to 338 centimeter cube, which will be the volume of the sugar syrup. Exercise 13.3. First problem, a metallic sphere of radius 4.2 centimeter is melted and recast into the shape of a cylinder of radius 6 centimeter. Find the height of the cylinder. Coming to the solution, given radius of the metallic sphere R1 is equal to 4.2 centimeter. Also the radius of the cylinder R2, which is equal to 6 centimeter. Let the height of the cylinder be h, which is unknown. In the problem, a metallic sphere is melted and recast into the shape of the cylinder, writing that the volume of the sphere is converted into the volume of the cylinder. Volume of a sphere is 4 by 3 pi r1 cube is equal to the volume of the cylinder is pi r squared h. Keeping the h on the right hand side and bringing all numbers to the right side, we get h is equal to 1.4 the whole cube, which is equal to 2.74 centimeter. Hence the height of the cylinder formed will be equivalent to 2.74 centimeter. Next problem, how many silver coins 1.7 centimeter in diameter and of thickness 2 millimeter must be melted to form a cuboid of dimension 5.5 centimeter into 10 centimeter into 3.5 centimeter. We know that the coins are cylindrical in shape. So it is given that the height of the cylindrical silver coin is equal to 2 millimeters equal to 0.2 centimeter. The radius of the silver coin will be 1.75 centimeter divided by 2, which is equal to 0.875 centimeter. Find out the number of coins. So I am considering let n coins melted to form the cuboid of the given dimensions. So I am writing volume of n silver coins is equal to the volume of the cuboid formed. So I am writing n into volume of the silver coin is in cylindrical shape. So I am using the formula pi r squared h, which is equal to the volume of the cuboid L into b into h. Substituting the we get that into pi into 0.875 the whole square into 0.2, which is equal to 5.5 into 10 into 3.5. Keeping n on the left hand side and taking the numbers to the other side and simplifying, we will be getting 1347.5 by 0.36875. Further dividing, we get 400. Therefore, 400 coins were melted to form a cuboid of the given dimension. Eighth problem. Water in a canal 6 meter wide and 1.5 meter deep is flowing with a speed of 10 km per hour. How much area will it irrigate in 30 minutes if 8 cm of standing water is needed? Into the solution, consider an area of cross section of canal with width and depth. We get the area of the cross section of canal equal to 6 into 1.5, which is equal to 9 meter square. Speed of the water is 10 km per hour. So I am converting kilometer. We get 10,000 divided by 60 meter per minute. Since canal is in the shape of the cuboid, the length of the cuboid due to a flow of water in a canal in per minute will be 10,000 divided by 60 meter. So the volume of the water flows in 1 minute from canal L into B into H is equal to 9 into 10,000 divided by 60. Further simplifying, I will be getting 1500 meter cube. Therefore, volume of the water flows in 30 minutes in the canal is 30 into 1500, which is equal to 45,000 meter cube. Let the irrigated area be A, which is equal to length into breadth. Height of water in the land centimeter, converting to meter, we get 8 by 100 meter. Since 8 centimeter of water standing in the land, so this becomes the volume of the water flows in a canal in 30 minutes will be equivalent to the volume of the water cuboidal area. So which is 45,000 is equal to L into B into height is L into B, which is called as area. Area into height is 8 by 100. For this simplifying, I will be getting the area as 5,62,500 meter square. Converting the area to hectares, 1 hectare is equal to 10,000 meter square. So the area irrigated in 30 minutes equal to 5,62,500 meter square. When we convert this into hectares, that is divided by 10,000, we will be getting 56.25 hectares.